Okay, hello everybody, and I guess welcome to SOS 315. This lecture is in place of the lecture that should have been done in person on September 16th, 2024. As you all will likely know, the projector was broken, so we were unable to do the class in there. I thought of a genius solution like 5 minutes after you all left that could have made the whole thing work. But, as per the usual, I was 5 minutes too late in my genius thinking. So, no worries, we're good. All right, so this content, we're just kind of continuing on talking about research design, and this will take us most of the way through. The lecture looks like it is about 45 minutes long. So I will, just keep in mind, this was recorded a couple of years ago for a summer online version of this course. So if I use any examples that seem a little bit dated, I apologize. It is what it is. Okay, so I'm going to shut up and go to the next slide where I am already talking. And yeah, please watch through these. Come back with any questions on Wednesday, September the 18th. We will see you all then. Okay, so ideally, right, if everything goes right, changes will only happen in your treatment group or your experimental group, right? If changes occur in both your experimental and your control group, well, that means that basically there's a third variable that is causing the change that you aren't either aware of or you're not measuring or whatever it happens to be, right? Like if potentially, okay, so our question of caffeine versus words remembered. I know it's a boring example, but I couldn't come up with a better one. Caffeine versus words remembered, right? Okay, so your group that you give caffeine to, they go from remembering 25 words to 50 words, and your group, who are your control group, who you give, filthy brown water that you call decaf coffee, but is really just a lie and a sin, that group also improves in roughly the same proportion. Well, then you have to look for, then the relationship is spurious, right? Then the relationship is not being caused by your manipulation of the independent variable, but by some other external factor that is triggering some kind of change. So basically, then A, your experiment's invalid, and B, you just made people drink decaf coffee for no reason, thus polluting their bodies and their souls. So yeah, I mean, if changes occur in both, then the relationship is spurious and it's caused by something else, and you need to go back to the drawing board with your explanation. So maybe in that case, right, it's just being in the lab that causes people's behavior to change. Okay, yeah, so true experimental evidence, basically should eliminate all other possible or rival explanations for the change in the dependent variable, right? It should be kind of isolated. And this is, again, why in social research it's really difficult, because people are so complicated that it's really hard to eliminate any rival explanation, right? But if you get the conditions where, your treatment group, you see a big change compared to your control group, then yeah, you can eliminate rival other possible explanations. Then you've got sort of a true experimental evidence or really high validity. Yeah, most social experiments, like I said, they involve complex issues. So you tend to have pretty large groups, control groups, really random distribution of subjects to hopefully increase their internal validity. But they're not very common, right? You don't see a lot of social experiments for the reason that, the kind of questions that sociologists ask just tend to be of a different order. Okay, so we need to talk a little bit about the question of validity when we talk about research design. So validity in social research, what is it? Well, basically it is an assessment, of to what extent a research study addresses the issue the research was intended to actually explore, right? So, I mean, if you look at my little image here, right, it's an illustration. It's obviously not perfect, but what you can see is, right, let's say the target and the center of the target is your research, is what your research was intending to study, right? If you're not at all, like if you're in that first one, unreliable and invalid, right? If you're not at all on target, right? If you're not really hitting the target that you were aiming for, you're not, able to address the issue that your study was meant to address, right? You're the top one or the top left side or the bottom left side, right? You are off the target and you're not really answering things. The bottom left side, you might be looking at it like everything's clustered together, like your findings make sense, they're reliable, you're getting good data that generates results that are consistent, but it's not valid because it didn't actually address the thing that you are trying to address. So that's validity. Okay, internal validity is concerned with the extent to which what is interpreted as the cause of a phenomenon, right? So what you see as the cause of the phenomenon from the results you get actually produce the effects in a given piece of research. So basically, to what extent the research design is a good test of the hypothesis under consideration, right? So does it really answer the question that you posed, and is the research design helping you actually test the hypothesis under consideration, right? So is it internally valid? Does it answer the question you wanted it to answer? Does it study the right thing, right? And so the example given in the textbook here, did the study establish that personal income levels in Canada really are really influenced by one's level of education, right? Or is it that the more educated tend to have higher incomes? Or could there be something else, right? So if there could be something else, then your study is not on point and not valid because it's not addressing what you're trying to research in the first place. Okay, so Cook and Campbell outlined some threats to internal validity in experiments that lack random assignment or the presence of a control group, right? So a control group is really important in experiments for establishing validity, right? Okay, so history. Some event occurring after treatment was given that may have influenced the dependent variable. Okay, so here, let's say that we're trying to measure the effects of screen time on mental health, and we run smack into COVID-19, right? And then there's an external factor affecting mental health, which is isolation, right? That could be potentially, right? Some historical event. Testing. Whether the pretest might have influenced the dependent variable, right? Sometimes, in experimental settings, just being in an experimental setting and giving people a test can change the whole thing. Accidentally, your pretest causes, a change in your dependent variable, which you would be aware of if you have a control group. But if no control group, then obviously that doesn't work. Instrumentation, right? If there's some technological change in how a test is administered, between the pre-test and the post-test, a different technology, or you're doing it in a different way, that can affect things. Mortality. Somebody leaves the experiment before it's over, potentially for dying. Maturation. Participants change over time. So if the span of your experiment is too long and say people are growing up, right? If you start testing on people that are 6 years old and you test them again over time when they're 9, well, then you're talking about people with different developmental levels, right? And things will be different. So you're going to get different results for that reason. And selection, right? If you don't have good random selection, you might get, changes caused by pre-existing differences, right? So you need to make sure that things are well randomized. Okay, so measurement validity or construct validity involves questions of, whether you're measuring what you want to measure. Okay, so for example, IQ tests, might be a way of measuring intelligence or academic ability or some such thing, right? We saw that in the example with the spurters and the non-spurters, right? You had a T1 IQ test administered the prior year, and then one administered after teachers have been told that a group was, spurters, and then you get your control group. IQ tests, though, there's a lot of criticism of IQ tests and whether IQ tests actually measure what they intend to measure. Some people suggest that they actually don't measure intelligence particularly well, but they measure sort of a lot of cultural ways of knowing, and that's why, in some cases, people who are African American don't do as well as on IQ tests. It's actually measuring, cultural factors in some ways more than intellectual factors. So if you're using IQ tests to test intelligence, you would have to be questioning whether you're actually measuring intelligence or academic ability, or if IQ tests themselves are sort of biased in a certain direction. And that's, an important question when you're doing an experimental type of research. Okay, so external validity, another form of validity, and there's two kind of primary concerns with when it comes to external validity. But basically, can you are the findings of your research applicable outside of your research environment, or are you only able to measure things done within the environment? In which case, not that that's useless, but it's less generalizable. And of course, for social research, then it's much less interesting. And can the findings be generalized beyond people or cases studied? And here, right, a representative sample is usually the way that we get around that, right? A large enough sample and one that represents the population relatively well, right? This is what you're going to want, broadly speaking, when we're talking about a representative sample. Okay, so threats to external validity. According to Cook and Campbell again, basically, the representativeness of study participants, right? If you don't have a good representative sample, then you can't generalize out to a wide group of people who are not in the experiment, right? Your results will be limited to basically what, to the group that you studied. So less interesting, right? The effects of setting, right? The findings might not apply to settings and environment that differ from those of the experiment, right? So it may be that if you're looking at too specific a place or a time, it may not be generalizable. Pre-testing, right? The effects, the findings might not apply to people who are not pre-tested if the pre-test affects people, right? Again, so this is where having a control group makes a big difference. You can kind of judge that. And then reactivity, sometimes just an experimental effect, right? The fact that people know that they're being observed changes how they behave, and that can, invalidate your results, right? Because if people start behaving, it's like reality TV, right? That people act differently when the cameras are on than they do when the cameras are off, right? This was always the problem with shows like Survivor and Big Brother and any of these shows, like, it's not real life. Because that, people act differently for the cameras, right? That's reactivity. And so reactivity, if you're getting a reactive effect in an experimental arrangement, right, this can invalidate your findings because the subjects are not behaving as they normally would. Okay, replicability for any kind of social, like for social research and social experimentation is really, really important. And I'll give you a pitch at the end of this, just why we're actually in a replicability crisis, both in the hard sciences and in the social sciences today. But replicability, basically, the results remain the same if others repeat all or part of the study, right? Basically, someone should be, so you should spell out your procedures, and you should have thought them out well. So that, and the idea is, right, that I could take your experiment or your research and I could run the numbers myself. I could do the same experiment over again and come up with the same results, right? So it should be replicable. And this is important, right? Because then if you can back things up by numerous studies, then basically, broadly, that should show a high degree of validity. Okay. So, I said there's a replicability crisis in both the hard and the social sciences. Okay, one of the problems with this is sort of found in the publish or perish nature of academia, right? There is very much, right, how many things have you published? You're supposed to publish 1 or 2 articles a year as a tenured faculty. If you're on the tenure track and you're trying to get tenure, it's 1 or 2. And then you're trying to get a book, So there is a pressure to come up with novel, sexy, kind of interesting findings. And that wouldn't be a problem, if it was just for a few people that we were trying to come up with something novel. However, one of the big problems that happens is everybody's trying to come up with novel and interesting findings. And so in a lot of cases, nobody ever bothers to do a replication study, right? Nobody ever bothers to apply for funding from one of the big agencies, SSHRC or NSERC in Canada, and then they're different in the US, of course, to say, I'm going to spend 2 years doing a replication study of this thing that's already been published. Now, people may put in those kinds of applications, but because they're not sort of fun and interesting, it's not going to produce novel results, they're less likely to get funded. So you're less likely to be able to do that research, which means a lot of studies, both in the hard and the social sciences, or the natural and the social sciences, are run once, and nobody ever really attempts to replicate them. So when you read, a lot of things in the newspapers, right? This study found that XYZ. One of the, and whether that's like 10 glasses of wine a day is likely to decrease your, possibility of cancer and your ability to do online lectures, or maybe actually 10 glasses of wine would make listening to online lectures more bearable. I'm not sure. I'm sure it would affect, short-term memory at the very least, though. I am not at all saying you should try it. And frankly, if you're going to drink that hard, you should probably be shooting whiskey. But, no one, so someone says like, 10 glasses of wine, let's say a week, increases the ability of students to tolerate online lectures. If nobody ever goes back and checks that result and runs it again, right, that first result often lacks validity. And it's hard to say whether this was just in a weird circumstance or even if a researcher manipulated results. So there's a lot of studies out there, and again, both in the social sciences and the hard sciences, that no one's ever attempted to replicate. And so, the results may very well have been doctored by a researcher with an ideological agenda, or someone who was just trying to come up with results so interesting that it was guaranteed to be published and he was going to get notoriety and lots of citations and all these things, because citations by other scholars matter too. So, if you're pretty sure that no one's ever going to bother to try and replicate your study, it changes the way you do research and it changes the way you might interpret conclusions. You can go out a little bit further into left field. And this is becoming a real crisis in academia. Not nobody, literally, but fewer people do replication studies, right? And so, I would love to see, and maybe, I don't have the ability to do this, at least not at this stage in my career, but I would love it if someone just founded the Journal of Replication Studies, where the whole journal guaranteed that people who did replication research got published in a reputable journal with high standards, double-blind, peer-reviewed, all that stuff, but the journal only publishes the results of people who've tried to replicate other people's research. I would love to see that. Maybe, if I ever get to the stage of my career where I have the ability to found a journal and some cash, I would love, love, love to do that, because I think it would be super important work. Or maybe all y'all, as you venture out into the world, think about doing this, because it's a real problem. And the fact that nobody bothers to do replication studies because we're so wired in the academy to novelty is something that's it's going to come back to haunt us at some point as a kind of sector, because there's a lot of bad research out there that just nobody has bothered to check the results by doing a replication study. And if they did, there's a ton of stuff. You could make a name for yourself as a researcher finding the holes in other people's work. You wouldn't be popular, but I guarantee you'd get some headlines. So think about that. Maybe I'll think about it too. But again, I'm not at the stage of my career where I can do that. But it would be a worthwhile venture. So keep that in mind. Okay, so laboratory experiments, for all of their potential problems, do have their place, obviously, and advantages, right? You have greater control over the environment, so you can make sure there's less possibility of interjecting, third variables, things that would make your findings spurious. It's easier to assign participants randomly to conditions, right, if you're controlling all of that. And it does come with some limitations too. Low external validity, right? And the lab is kind of life in a test tube. You can't really always say that what you find in the lab conditions is going to be applicable outside, right? Stanford prison experiment. You can't make generalizations outside of that context. Same thing with the one where, the guy shocks the guy in the other room because they think that's what the experimenter wants them to do. All of that, right? It's hard to make any claims outside of the lab condition on that kind of stuff. Okay, so there are quasi experiments, as well, where sometimes things happen that can cause, a big change that then, kind of almost functions as an experiment, but, isn't set up in a lab condition. Okay, so I'll give you an example in a second here. So quasi experiments, right? So differ from true experiments in that internal validity is harder to establish, right? And you've got less control over variables. Lots of different kind of quasi experiments, but one that the textbook flags and I think is kind of interesting, especially given our kind of position currently in history, is what would be called natural experiments. Okay, so natural experiments, basically experiment-like conditions are produced by naturally occurring phenomena or changes brought about by people not doing research. Okay, so you can think of the situation that we're in right now, right, with COVID-19. I know we're all sick of talking about it, but it's a good example of this, right? And suddenly people have been thrust into a greater degree of social isolation, right, brought on by lockdowns and a need to keep away from people, more screen time, less personal contact, less exercise, all of these sorts of, less venues for going places and interacting with people. And so this, while it is tragic and it sucks and I hate it, does present an opportunity to, do surveys, do measurements, do all sorts of things to gauge what happens to people when they're put in a super stressful situation, when they're forced to isolate away from people, when they have to spend a whole bunch of time by themselves in front of screens, like I'm doing right now, recording this lecture for you. All of this, is, I think, a natural, good, in a sense, natural experiment, right? Because we're seeing the effects of a lot of different things, not things that we controlled, right? Not things that have happened because we set it up in an experiment, but we do get to watch, kind of what happens and how people react to these sorts of things. And we can do lots of different things to measure kind of what's going on. Okay, so another type of study is called a cross-sectional study or cross-sectional design. And you can think of a cross-sectional design as basically like a snapshot in time kind of design, where you're not attempting to measure things using any kind of before or after comparisons. You're trying to take like a read of a particular moment in time. So there's a lot of this kind of research that happens, right? The research study that I was talking about that I was involved in, or that I was actually the PI on, which was, looking at, in Edmonton, what are people's attitudes about Catholic agencies? This was a cross-sectional study, right? Where I just took a snapshot in time. So in 2019, what do people think, right? We're not going to compare it to before and after data. We're not going to manipulate any variables, right? There's no treatment. We're just going to offer a questionnaire to measure people's kind of opinions or ideas right at this moment in time. So this is basically a really common type of design if you're generally looking at doing your research yourself. Part of the reason is funding. To go with a longer term study is typically expensive and requires, a lot of secure funding for the long term, right? So that you're not begging for funding. You do your one kind of study and then you want to do a follow-up study, and you can't do it because you ran out of funding. So funding is always a question. Cross-sectional designs, right, are good for just taking a look at where things sit right now. And then, you can make some observations based on that. And typically, right, you'll measure two or more variables in order to detect some kind of pattern. And usually like you're doing more than just two variables, right? You're going to measure a whole bunch of variables and then kind of use a bunch of statistical wizardry to kind of look for patterns between them and typically correlations, right? Whether, things like age or gender or race, or whatever, affect, church attendance or amount of coffee consumed or, beliefs about, XYZ. It doesn't really matter. Like whether marijuana should be legal, right? You can do that in terms of a cross-sectional study. And you can sometimes see correlations, right? You can see, that two variables are linked. And a correlation is basically just a link between variables, right? Where you might see that, as people get younger, fewer of them attend religious services, right? Older people tend to attend more, younger people tend to attend less. Or, younger people will tend to have, more liberal attitudes, regarding drug use, especially marijuana, right? So you can see these kinds of things, these things are correlated, right? It shifts on the scale based on age, right? Or you could look at age and life satisfaction, right? You could see kind of, the sliding scale again. As people get older, they tend to be more satisfied with their lives than younger people are, and this sort of thing. So these things can be linked without necessarily, being caused by one another. And this is, I think, with cross-sectional design, always the thing to remember. And with most sociological research, correlation does not equal causation, right? It's hard to say that one thing causes the other, like one phenomenon might cause the other one. All you can say is that they're linked in general sense. Now, I mean, you can make a strong case in some cases, right? If we see a long-term and consistent kind of trend of two things being linked in numerous studies, then you can start to say, yeah, these are multiple correlations which point towards a causation without ever being kind of totally deterministic about it. Okay, one of the other kind of big questions when we look at a cross-sectional type of design is that there do tend to be issues with internal validity. Right, and particularly with the direction of causation. And here, is a good example. A researcher might find, a positive association between self-esteem and income, right? So as income rises, self-esteem rises, or vice versa. But where it becomes really difficult is to determine which one is the cause and which one is the effect, right? The directionality. Which one is sort of pushing the other one in a particular direction is the thing that can be really, really difficult to determine. Or is it, and here, so is higher self-esteem leading to higher levels of income, or higher levels of income leading to self-esteem? Or is there a kind of reciprocal causation, right? Do they kind of march in almost a dialectic lockstep where, as people with more self-esteem take more risks, and therefore they tend to get higher incomes, which then raises their self-esteem even more, and allows them to take even more risks, and then, kind of up and away to infinity and beyond, if you will. I hope the Buzz Lightyear jokes are still a seller in 2021. Right, but okay, so you get this idea, right? Figuring out which variable causes the other one in a cross-sectional study is really difficult. Just because all you have is a snapshot and all you see is that, okay, people with higher self-esteem on these markers, you design some survey questions, will have, a higher income. So that is kind of one of the big problems with cross-sectional design in general. So you can also have problems with external validity when it comes to cross-sectional studies. Generally, right, to have external validity, you have to have some kind of random method used for selecting participants for the study. If it's not random methods, the findings might not hold for people who aren't studied. And this makes sense, right? Like basically, sampling a random population is really important to establish kind of the statistical validity, right? You need a representative population for one, you need a large enough sample so that you can extrapolate things, and all of this kind of stuff. And so, I mean, this can, depending on, how you're working things, be really, really difficult. And here, okay, so like, this is why, when it came to the study that I did involving Catholics,
we used a polling agency. So, right, we used Abacus Data, an Ottawa-based public opinion survey firm, because Abacus has access to a huge database of people who are willing to answer surveys, and so they can sort of send it out to enough people to get our sample and to get a representative sample. Even then, broadly speaking, because it was an internet-based sample, there was a bit of a problem, and we sort of had to admit this in our findings, was that it's not perfectly random, because it ends up being only people who have signed up for different web survey platforms who are available to answer the survey based on a web-based sample. Which means that it does skew a little bit younger, because older people tend not to sign up for these sorts of things. So you can have a little bit of a bias in the data there. And we worked on the statistical side to correct some of these things, but that problem always kind of exists if you get people who have signed up, they're a different kind of person, and so it may not be truly a random sample. Now, this is broadly a problem with surveys today in general, where we used to be the best way of doing it was phoning, right? And you would just do random calling and hope that people picked up and that you would get your response that way. But because of call waiting and the fact that people have cell phones and not landlines, this has become fundamentally much more difficult, and public polling is in a kind of catastrophic state because it's really difficult. Also, phone sampling is unbelievably expensive, 10 to 20 times more expensive than doing the sample by internet, for obvious reasons. You have to actually have someone make a phone call and talk to someone, and that can be awkward at the best of times, and lots of people don't pick up, right? Or lots of people will hang up the second they hear that it's a polling company. So this is a problem. Cross-sectional studies increasingly face these kind of deep methodological problems, and so getting a random method and a good random sampling of people is particularly difficult. You see this too with public opinion surveys around elections. You have lots of these I can't remember the ones in the U.S. Are like an MSNBC, and Harvard University study that's going on, an internet-based sample, and you'll see 5 or 6 of these come out over the course of an election. The problem being that it's not truly random, because they just keep surveying the same people over and over again, which is why in pretty much every election recently, the polling has been extremely off. And it's just that we don't have a good solution to this. We haven't figured out a good way of getting the data we need. And this is a big problem for cross-sectional. You might not be able to say that this represents everybody if it only represents people who are signed up on, the Abacus Data kind of web polling platform, or whatever it happens, Angus Reid, or whoever it happens to be, Ipsos, all of these things. So, you do need to take that into account, and external validity can be a big problem. Okay, so when we talk about cross-sectional designs, on the whole, cross-sectional designs for research do tend to be quantitative, right? It's much easier to do a quantitative cross-sectional study than a qualitative one. That said, it is possible to do a qualitative cross-sectional kind of study, right? So you can, set up, typically I would say semi-structured or unstructured interviews, and sort of ask people, about eating habits, what causes them to eat a certain way. And if you do enough interviews, right, if you say did 200 interviews on, people's exercise habits and what gets them out the door, in the morning to go for their run. In theory, right, you could code the data, right, pick out all the instances of certain keywords or certain things that people are saying, put it all together and suggest that, X, we can see that at this point in time, these are the kind of trends we see in the qualitative data, and people who exercise tend to exercise for these reasons, and, blah, 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 all of this sort of things. You can do that. Now, I think actually the most sort of interesting way of doing cross-sectional research that involves qualitative data is to, I mean, here I'm probably showing my biases for the research projects that I've done, which I've used exactly this design, is that you do a kind of quantitative study, right? So you'll send out a questionnaire or two, and then you use the information that you come up with in the quantitative study to fashion your interview schedule or your interview questions when you talk to people, so that you're able then to basically kind of query some of the patterns you see in the quantitative data, and ask about like the internal reasons that people act in certain ways or hold certain opinions in a qualitative way. And I think that tends to be a really enriched way of doing, a cross-sectional study using both quantitative and qualitative data. So, I mean, it works really. You can do it, both just on a straight quantitative level, which is really the most common one. You can do it using, qualitative methods, though I do think it's a little bit harder. And then I think the richest example, the one I just gave, is using a mixed method, right? Where you use both quantitative and qualitative to inform each other. And again, generally what you're going to do there is you're going to take the quantitative data and use it to make, to ask questions to people, to get that qualitative kind of insight. And that, I think, again, I think it's a really sophisticated and really deep way of doing a study that tends to yield really, really rich results. Like, for example, like I think one of the best studies, that was, okay, actually that's a longitudinal study. So I'll maybe skip that. We'll talk about it when we talk about longitudinal, which also had this qualitative approach. But I've seen lots of studies that use this kind of method, and they can be very, very rich. And so we'll go from there. Okay, so this is, the kind of data rectangle of a cross-sectional design. Or cross-sectional research, and it's pretty straightforward, right? So you've got your observations, observation 1, 2, 3, all of, n represents like total number, for different cases, right? So you can be observing like income, and you could have it, different cases for people, for say households, for cities, regions. Those would be your cases, right? So you can measure those things, or happiness, or whatever. There's a million different things that can be your observation. Any kind of data variable you ask about is an observation, and it's, and then your cases, right? Who kind of you're asking about and what you're measuring there. So that's how it basically looks if you grid it out. These could obviously get huge, and this is why we have sophisticated software like SPSS to deal with a lot of this data. Okay, so the next kind of study that we can talk about is longitudinal study. And basically a longitudinal study, the idea is, basically cases are examined, at time one, at a particular time, you mark that as time one, and then again at later times, time 2, time 3, time 4, etc. You may follow people for 50 years, depending on the study. These designs, basically are supposed to show changes over time, right? How, wealth increases over time, or self-esteem, or views become more conservative, or whatever it happens to be, right? Like you could kind of look at that over time by sampling, people in a couple of different ways. We'll talk about that on the next slide. Longitudinal studies, right, tend to be good for figuring out the direction of causation, because you can then figure out sort of where, as opposed to a cross section, you can figure out kind of if there's a change over time, and then see what factor kind of correlates most strongly with that. And then you can see the direction of causation, right? So if people tend to become more religious as they get older, what we'll broadly see is, is that, showing up, increase in religiosity and increase in age moving at the same time. And we can broadly say that, the increase in age is going to be the thing that causes the other one, because, obviously being more religious isn't going to cause you to age. So you can kind of see the directionality there. I mean, this is maybe not a great example, but, regardless, we can kind of look at that. You could look at that for declines in religion too, and sort of see where that goes, at what points in life people are kind of up and down. So if income, I'll read that. Income's observed at T1 increases an increase in life satisfaction occurs, and at T2, you can sort of say that there's evidence that increased life satisfaction was preceded by increase in income, right? So, we can see those sorts of things, and we can see then the directionality of those factors. Okay, so I think that makes sense. So, you can have two basic kinds of longitudinal studies: a panel study, which is like the same people, households, organizations are studied at different times, lots of examples of these, and then a cohort study. Basically, you would take like an age group, like people, born 1982 to 1992, right? And you would do kind of a survey of people that fall into that category, at different points in time. But you wouldn't get the same people each time, right? You would do a random sample each time. And each of them has kind of their advantages. Okay, so for a panel study, one of the ones that I like as an example is the National Study of Youth and Religion out of University of Notre Dame. So basically, this was this great big study. It started in about 2001. And basically what they did was they surveyed 3,000 teenagers and their parents about kind of a whole bunch of issues like income, outcomes, behaviors, religious attitudes, and all sorts of things. 3,000 of them, and they also did, along with this, a set of interviews of about 10% of the sample, so about 300 youth. They then went back 5 years later and tried to find the same people. They didn't add any people to the sample. They tried to find the same people. They lost some. They just couldn't contact them again or find them, but they tried to contact the same people and kind of checked in with them, 5 years on, and then they did a third round where they checked in with them, 10 years on from the original study. And basically, right, this is to track changes over time. A cohort, so obviously that has kind of consistency, right? You're following the same people, so kind of what the variables for the individuals that you're dealing with were at each kind of point, right? You can broadly say what the whole thing looked like at each point. A cohort study is a little bit less precise in that way, right? You're not as certain what's happened to people in the kind of intervening period. So, each one of them has its own purpose, but at the end of the day, they're both valid kind of forms of research. Okay, so what are some of the drawbacks, especially on a panel study, right? You'll have attrition over time, right? At some point, some people are going to die. Even if you're sampling a relatively young sample, you're going to have, people who die. You're going to lose track of people, right? People move around, people change their phone numbers, people leave no forwarding information. Especially now, this is increasingly difficult with the fact that you can change your cell phone number, in about 35 seconds. It becomes increasingly difficult over time to keep track of the same people. So you're going to lose people. So your sample, in a sense, in your first wave has to be kind of overly big to account for the fact that as time goes on, it's going to get smaller and smaller, and therefore, kind of shrink the representativeness of your later waves of the same study. This is, like the National Study of Youth and Religion had this problem where basically, right, they sampled, people in 2001, and then, when they went back to sample them again 5 years later, the sample dropped from about 3,000 to about 2,600, right? They lost about 400 people. By the third wave, the sample was down to about 1,900, where they had lost, over 1,000 people kind of in the intervening period, which is just like, it's easy to lose 1,000 people in a country of 360 million, and people not to leave a forwarding address or change their name, right? Especially if they get married and these kinds of things, right? So attrition, not necessarily always people dying, but that obviously does happen, but also just loss of contact with your panel participants. It can be hard to figure out when to do the follow-up study, right? Like, what is a sufficient period of time in which to kind of do your follow-up study? Like in the case of the National Study of Youth and Religion, right, they were targeting young people who were just in their last year of high school or coming, the last couple of years of high school, right? So they were between 16 and 18, and then they wanted to follow up them roughly when they were coming out of college, which kind of makes sense, right? They planned it around life transitions, and then, again, when they would sort of be then emerging adulthood, and into kind of the 30s would be that kind of third wave, and to see what had happened in the intervening period. That one kind of makes sense, but for other studies, right, it might be like, well, what is a big enough amount of time for us to leave it before we follow up with the same group of people, right? Should we wait 5 years, 10 years? What's the kind of natural transition period, right? And there's always going to be an arbitrariness to that decision a little bit. There's not anything saying necessarily that is there's a right or wrong answer here. And then panel conditioning, right? Just being part of a repeated study. People, their attitudes and behaviors might change as the result of being part of a panel. They might, actually change the way they answer questions because they know the kind of questions you've asked in the past. So there can be some slippage here as well, and that can be a little bit of a problem.